All right, so we are on right now. Um, we want to take a look at the circuit here and do the transfer function using the bond graph method, and then we're going to go to MATLAB and analyze that. Okay, so I'm going to disappear from here, and then so you concentrate on more interesting things than on my hair or something. And here you say go one, and then we had one for the current I1, and this was I sub 2, and then we had the element in here that see this is a C element in here. You have this R element which with value R sub 2. This is with value C, and then you have this one. I'm following the procedure as we learned before. This is value R1, and we have this in here source of flow with value I of t like this. Okay, so in here you have this in between this zero junction in here, and so we had this I element in here with value L. Okay, and this is what we had. So what we're going to do right now is we are going to go to the Campg software and enter this into that program and then obtain the transfer function. But before we do that, we need to establish to see what is the which one is the input and which one is the output. So I believe that what we need to do is, let's put this here, new, and then let's move this window down a little bit so that we could actually see the bond graph model that I had on the left hand side over here, and then I'll just draw it here. See, so I go in here and I do the SF in here, which would be this one. I'll put it on the screen in here, and then I do the one. So we go from here to here. In this case, we will just building it the way we would like also the bond numbers to look like. So this would be from here to here, and then you have the 0, which goes from here to here, and then we have an I element, or we put it here like that, and then you have a 1 in here from here to, do you see what happens? Just to remind you, these causal marks are assigned by the computer automatically, so we don't have to worry about that. And then we finally have to put the C element in here, and that completes the bond graph model. So one thing that we need to establish completely is here on the left hand side, what are the outputs? What are the outputs? So in here I'm going to write it down. Sorry, it means we need to go over here and let's see. Is it that we need to switch to this screen? So let's just write down in here what are the outputs. In other words, these are the ones that we need to get the transfer functions. Okay, I believe the 2 that we had was I sub 2 is the question. So we're gonna call it I. Okay, and here the transfer function that we would like is, this input in relation, sorry, the output is what I need to name before. So let me erase this, and then we go back here. The output is going to be I sub 2 of S over the input is I of S, like this. I put I1 in here, but I think I'm going to call it source 1 because, well, but it's the current, so if it is confusing, well, let's just go on. So here we have voltage C. This is the, also we would like to know what this is. The transfer function 2 is gotta be voltage C of S divided by the input in here, like this. Yeah, this is what we want. So once we have entered the bond graph model, and in here we go and we say interface, okay, do interface to the MATLAB, and then what is going to happen is it tells us what it asks us what we would like to do, and at that point we will select the two outputs that we need to get the transfer functions. And so that's immediately what we need to do. As soon as Campg and MATLAB interface with each other, and then they get this transfer function going for, we want the two of them. We have seen so far how this is done by using the matrix equation of state space, and knowing the A, B, C, and D matrices. We can use um, the expression that we obtain to obtain the transfer functions. That you may recall it has a combination of matrices on them. So in this case, so that we look at this very clearly, I am going to go to the, I'm going to modify the font in there so that everybody can see this really well. And I think number 18 is good. And I would like to put this bold so that everybody can see really well here. So what we're doing is we go to the CAMGSYM file, and we are going to look at what those outputs are. So the output that we need is, let's see, here. In this particular case, we need the current, and we're going to do it on this bond as well as on this. So let's take a look at what the bond graphs model says. In fact, we can go over here and bring it back so that we know exactly what, oh, sorry, wrong software. Here we go. We go over here. This will bring back our bond graph model. And then we know, you see here's F5 and F5 and E7 are the current I2 and the voltage on the capacitor, what we want. So what we need to do is, let's go to the where the MATLAB is in here, and then we are going to search for the for this where it says find. You just type F5 and we go and find F5. I call it what I call activate this 3 lines. What you are doing in doing this is you are defining the first output, and then by putting this as the first row, you are basically constructing the C and the D matrices as that's the first output. And because we have a second output, which is E sub 5, we also do the same thing and obtain the second output there. And once we have done that, we should be all set to obtain the transfer functions of these two. Oh, you're right. I think it was E7, right? So let's go back here and yeah, because this is not this cannot be the one. So it's E sub 7 now. Sorry. Let's just go here, and then we have this E7, which would be so we put it, go back here and say E7, and then we do the same thing. We'll activate this, and then we have output number 2 is what we have, and this way we put number 2 over here and 2, and we are done. So what we're doing, see, we will run this, and what I'm going to do is perhaps move this a little so that we are able to see. Let me go a little more in here. Let's just divide it here like that. See, in here you have the outputs, and you will have the A, B, and the C and the D matrices. It will give you the characteristic equation, and then it'll give you the two transfer functions that you want. So this is the one for the current, and the one on the bottom is for the voltage. So you obtain automatically the transfer functions in here. You could you know, play around with these expressions and putting any, you could divide by C7 and ISO4 and only leave the S term in the numerator, or you could leave it like they are. The point that I am making here, which is I believe is the important fact, is that I want you to concentrate on this. And this picture helps us a lot, because take a look in here. This coefficient influences whatever the term in here on the characteristic equation is, and so does this. And these are the physical parameters that influence the behavior of the system. So what we need to do is we give some numbers to the parameters, and what I would like to do is to concentrate as to, for example, what happens if we change C7? And what happens if we change R6? And now we're not going to guess. We are going to deliberately direct the project ourselves, in the sense that, okay, do I want more damping on the system, or do I need more stiffness on the system? What do I want to do? And depending on what I do, the behavior of the system is going to change. And that's what I would like to do. In other words, I think we have gone past how to obtain the transfer function. Right? We can do it automatically, or we can do it by hand. But we are there now, and we didn't do much effort. The point now is go over here to the top here, and then give numbers. So at the beginning of the file, you have the opportunity to do that. See here, I think is you go over here, and then this is in here we're gonna give some numbers. Like I think I gave it a 1, then I give that like this, a 3 like that, and I believe this was like just to get something going, and I think this was 1 over the stiffness, so I put it like this value here. That gives sort of reasonable results for this illustration that I'm making. So right now, if you were to run it, Um, it's not gonna show here yet because you know this the old one is still running, but now it does. See, now they are numbers. Okay, so we change it to the numbers, and the characteristic equation is also numbers, and so are the transfer functions. At this point, Campg has delivered this information to MATLAB in such a way that is saying, look, MATLAB, with the transfer function number 1, obtain for me the input and step impulse and step response. Also do for me a body plot, which is called frequency response, and also do for me a root locus plot. Okay. Right now, so far, we have analyzed the step response, impulse response, and the body plot. Let's leave the discussion of the root locus plot for another lecture. But at this point, the computer knows the values, and what it does is goes to the control systems toolbox in MATLAB and totally transparent to you went ahead and did this analysis here and made this plots for you. So you can see that in here the input and the impulse and step response is shown in here in the step response for the first transfer function and the step response for the second transfer function. In other words, this is the current one, this is the voltage one. Same thing here for the impulse response. But I think so that we illustrate the point that now we are going to take it for granted that we can get the transfer function and we can get it working. Now, like I said, we're going to direct the project, meaning we want to change things and see what the system does. So what I would do is, let's just give it some thought about this. You see here, you see this number 3 in there? It would be perfectly fine to go and change, let's say, number 3 to a 4 and see what it does. But, you know, we shouldn't just blindly change the number because we are dealing with a real system. So we actually need to change the parameters that make the system up, not just the number. I mean, what I can tell you is that people in industry and real life, this is exactly what they do. They tune in those numbers, but then they have the task to figure out where the coefficient came from. That's the point I'm trying to make for you when I had the transfer functions in symbolic form. This is what I'm trying to say. That number that you see on the bottom of the screen, that number is a 3. But the 3 is a combination of these two. You see what I mean? So you cannot just go and say, okay, let's make it a 4. Yeah, granted that you will obtain a result, but it is the product of C7 times R6 that is the 4. So what I would propose here is, why don't we change let's change R6 and see what happens when we change the coefficient in the middle of this. Let's change R6. And so I go over here. Do you see I have it in here? And I am not going to change C7, but R6. And I change it. R6 means more resistance on the second loop, right? Remember, so that the R sub 6 is, where are we? R6 is this one. So if I put more resistance, what do you think is going to happen to the current? Let's just reason this first. If R6 is big, bigger, I should say. What do we have? Like 3 was, we're gonna double it, you know? If R6 is big, I would expect the current to go down. Let's see if that's true. Because that's where our decision lies. So let me erase these ones in here so that we get new ones and go back over here. Let's make this a 6 just for testing purposes. And I'll run this. And so this is with a new parameter. Computer. Oh, wait a second. This did not change. Something. It did. Yes, it did. Because it's the product. Because it is the product. Okay. Do you see what I said? What I'm saying? Now there's not so much oscillations as it was before. Just in case anybody missed, I could go back and put it back. Although I think you see it, but you know, and here if we go to the editor and then we change this to 3 in here, you know, more, I see less resistance. Or let's go the other way. Let's change it to a 2. Yeah, let's change it to a 2 and see what happens. See, now we run it again. The computer does, you realize, see, it changed the middle coefficient. And this you should see more oscillations on this. In fact, that's what you see. So I think the lesson for this is that the coefficients of the system define what the transfer function result is going to give you. Now, I am going to do something a little crazy. How about if I set it to a 0? What do you think will happen? Let's see. That means that the coefficient of the S would be messed up, right? It would be 0. What does that mean in terms of the real system here? Let's see what happens. Because I think I'm getting across the point that I can actually change it and modify the response, right? But what about if I just go out and just plain make this a 0? Isn't it true that the coefficient of S is going to be 0? So in fact, in doing so, I modify the entire system. And I modify the transfer function. Let's see what happens. Run. Transfer function is going to give us, oh, look at this. Entire different transfer function by doing that change. What will happen to the response? What happens to the, oh, beautiful design, right? No way, Jose. This, we really messed it up. And that's what I wanted to demonstrate to you. The power that you have in control systems in modifying the coefficients of the characteristic equation. Okay, so we'll try next the mechanical systems, but we'll stop this for now.